Hi everyone, welcome to my channel Icon Teacher. I am Satya Prasad. In this session, we will discuss the first exercise from the first chapter of class 11th mathematics, that is sets. Now before we solve the problems of exercise 1.1, I request all of you to watch the first video on sets, that is sets part 1 and sets part 2 video lectures, so that you can solve the problems of exercise 1.1 very comfortably. So let's begin the problems. The first problem: which of the following are sets? Justify your answer. That is the first question. Now let us see the first bit. The collection of all months of a year beginning with the letter J. So the months of the year beginning with letter J are January, June and July. So which means it is a well defined collection, therefore it is a set. So it is a well defined collection, therefore it is a set. Now let us see the second question. The collection of 10 most talented writers of India. Well, we have already discussed that a collection of well defined distinct objects is set. So here when we say the collection of 10 most talented writers, here the opinion varies from person to person. So this is not a well defined collection, therefore it is not a set. So we write it is not a well defined collection. Therefore it is not a set. Now let us see the third question. A team of 11 best cricket batsmen of the world. So once again, when we say the keyword best, so this also the opinion varies from person to person. So it is not a well defined collection. Therefore again a team of 11 best cricket batsmen of the world is not a set. So it is not a well defined collection. Therefore it is not a set. Now let us see the fourth question. The collection of boys in your class. Well, this is a well defined collection because we can easily distinguish the boys of the class. So this is a well defined collection, therefore it is a set. Well defined collection, therefore it is a set. Next, the collection of all natural numbers less than 100. So the natural numbers less than 100 are 1, 2, 3, so on till 99. So once again it is a well defined collection, therefore it is a set. It is a well defined collection, therefore it is a set. Now let us see the next question. A collection of novels written by the writer Munshi Premchand. Once again, this is a well defined collection because all these are written by the same author. So it is a well defined collection. So we can call it as a set. So it is a well defined collection, therefore it is a set. Now let us see the seventh question. The collection of all even integers. Once again, all the even integers is a well defined collection, so it is a set. The collection of questions in this chapter. Once again, here if you observe the questions of the same textbook, so obviously it is a well defined collection, therefore it is a set. therefore it is a set. Now let us see the last question of the question number 1, that is a question of collection of most dangerous animals of the world. So again, when we say dangerous, the opinion varies from person to person. So the animal which is dangerous for one person may not be dangerous for the other. So the opinion varies from person to person. So we say that it is not a well defined collection. So we say that it is not a well defined collection. Therefore, it is not a set. It is not a set. So, I hope you understood the question, how to identify whether a given collection is a set or not. If the collection is well defined, then we say it is a set. I hope all of you understood this. Question number 2. Let A equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol in the blank spaces. So we have to fill in the right symbol in the places provided. So when we say that the element is present in the set, we use the symbol belongs to. This is called belongs to. And if the element is not there in the set, then we say it does not belong to. So this is a symbol for does not belong to. So in a collection, set A has 1, 2, 3, 4, 5, 6. That means 1, 2, 3, 4, 5, 6 are the elements that belong to set A, and any other element apart from this are not the members of set A. So they does not belong to set A. So that is a simple thing we should understand. So only 1, 2, 3, 4, 5, 6 are the members of set A, which means that only these members belong to set A, and the remaining members which are not in this collection does not belong to set A. So when the member belongs to set A, we use this symbol belongs to, and if the member is not present in the set A, then we use the symbol does not belongs to. So let us try to fill in with the appropriate symbols. Now let us see the first one. 5 is 5. You have to fill the right symbol here. 5, is it a member of A? So we could see 5 is a member of A. So we should put a symbol belongs to. 5 belongs to A. And if you see 8, the member 8 is not in the set A. So we should write 8 does not belong to. 8 does not belong to set A. Similarly, if you see 0, 0 is also not a member of set A. So 0 does not belong to set A. Now let us see 4. 4 is a member of set A. So since 4 is a member of set A, 4 belongs to set A. So we use the symbol belongs to. Then if you see 2, 2 is also a member of set A. So we write 2 belongs to set A. And again if you see 10, 10 is not a member of set A. So we use the symbol 10 does not belong to set A. So this is how we fill the right symbols. I hope you understood the question number 2. Question number 3. Write the following sets in the roster form. We have seen that sets can be represented in two forms. The first form is the roster form or tabular form, and the second is the set builder form. So here the questions are given in terms of set builder form, and we have to write its roster form. Let us see the first question. Question number 1. The set A is given as the set of all x such that x is an integer which lies between -3 and 7. So x is greater than -3 and less than 7. So let us try to find out all the numbers between -3 and 7. So the numbers are, so if you draw the number line, you could easily identify that between -3 and 7 we have say -2, -1, 0, 1, 2, 3, 4, 5, 6, and then we have 7. So we have to choose the values which are in between them, which are integers. So the integers are -2, -1, 0, 1, 2, 3, 4, 5 and 6. So these are the integers which lie between -3 and 7. So let's pen down this. In the roster form we write it as -2, -1, 0, 1, 2, 3, 4, 5 and 6. So this is how we write the roster form of the set. Let us see the next question. Set B is the set of all x such that x is a natural number less than 6. So we know that the natural numbers start from 1. So the natural numbers less than 6 are 1, 2, 3, 4, 5. So this will be the roster form of the set of all x. X is a natural number less than 6. Now let us see the next question. The set of all x such that x is a 2-digit natural number such that the sum of the digits is 8. So here we have to identify those 2-digit numbers whose sum of the digits is 8. So C is equal to the first 2-digit number whose sum is 8 is 17, because if you see 17, 1 plus 7 will be equal to 8. That will be the first 2-digit number whose sum is equal to 8. Then we have 26, 2 plus 6 is 8. Then we have 35, 3 plus 5 is 8. And then we have 44, again 4 plus 4 will be 8. Then we have 53, then 62, then we have 71, 80. So these are the possible 2-digit numbers whose sum is equal to 8. Next question. D is the set of all x such that x is a prime number which is divisor of 60. So let us write down the prime numbers which are divisors of 60. So the first prime number will be 2, then we have 3, and then we have 5. So the prime numbers which are divisors of 60 are only 2, 3 and 5. So the set D contains 2, 3 and 5. Next, let us see the next question. The set of all letters in the word trigonometry. So when we are listing down the elements separated by commas, we should ensure that they are all distinct or different. So we don't write with repetition. So whatever we are writing, all the elements should be distinct elements. So E should be containing T, then we write R, then we write I, G, O, N, then once again we got O, so we don't write O, then we write M, and then we write E, and then we write R. So R is also there, so I don't write. T is also there, I don't write. And then we write Y. So we have T, R, I, G, O, N, M, E and Y. So these are the all distinct elements of the letters of the word trigonometry. So this is how we write down the elements. Next, the set of all letters in the word better. So let us write down the distinct letters of this. So F is equal to B, E, T, and again we have R. So B, comma, E, comma, T, comma, R are the elements which are listed down separated by commas within the braces. So F contains only B, E, T, R. So this is how we write the roster form of the sets which are given in the set builder form. I hope you understood. Question number 4. Write the following sets in the set builder form. So the given set is given in the representation of the roster form or tabular form, and we have to write this in the set builder form. Now if you recollect, in the set builder form we have to look for a common property associated with all the elements of the given set. Now let us see the first question. It's given 3, 6, 9, 12. So what could be the common property associated with 3, 6, 9, 12? If you observe, they are all the multiples of 3. So let us write down this as, so we open the braces, and we write the set of all x and we put colon. So open the braces, write the variable. You can write any variable. So I have written x and we put a column which says such that. And here we are writing x is a multiple of 3. So x is equal to 3 into n. So it's a multiple of 3. Then n is a natural number. So we write n belongs to natural number. So n can be 3 ones are 3, 3 twos are 6, 3 threes are 9 and 3 fours are 12. So n can take maximum values 4. So we write n is less than or equal to 4. So the set builder form will be the set of all x such that x is equal to 3n, n belongs to n less than or equal to 4. Second question. The set contains 2, 4, 8, 16 and 32. Now let us see the common property associated with these elements. So if you observe this, these elements are in the form of 2 power 1, then 4 can be written as 2 square, then 8 is 2 cube, 16 is 2 to the power of 4 and 32 is 2 to the power of 5. So let us identify that the common property associated with all of these are nothing but they are all powers of 2. So we write this as the set of all x such that x is equal to powers of 2. So we write it as 2 to the power of n. Now n is a natural number, so n belongs to n. So the various values n is taking is n equal to 1 I get the first element, n equal to 2 I get the second element, n equal to 3 I get 8, n equal to 4 I get 16 and n equal to 5 I get 32. So the maximum value n can take is 5. So I write n less than or equal to 5. So this is how we write the set builder form for this particular set. Now let us take the third problem. The question contains, the set contains 5, 25, 125 and 625. So here also we can write this as 5 to the power of 1, 5 to the power of 2, 5 to the power of 3 and 5 to the power of 4. So we could observe that they all possess a common property that they are powers of 5. So we write it as the set of all x such that x is equal to 5 to the power of n, n is a natural number and n less than equal to 4. So this is how we are going to write the set builder form. Now let us write the next one. So question number 4, it contains 2, 4, 6 dot dot dot, which means it is an infinite set and all these numbers are the even natural numbers. So we can write this as the set of all x such that x is an even natural number. Even natural number. So since it is an infinite set, it contains all the even natural numbers. So it starts from 2, 2, 4, 6 dot dot dot, which means it is till infinity. Now let us see the fifth question. It contains 1, 4, 9, so on till 100. So we can write this as 1 and 4 can be written as 2 square, 9 can be written as 3 square and so on. We observe that the last number can be written as 10 square. So if you observe this, they are all the perfect squares. So once we identify the common property associated with the elements, now we can write this as the set of all x such that x is equal to n square. So if you see the first element 1 is same as 1 square. So we got 1 square, 2 square, 3 square, so on till 10 square as the elements. So we can write this as the set of all x such that x equal to n square, n belongs to natural numbers and n less than or equal to 10. So this is how we can write in the set builder form. I hope it's clear. Question number 5. List all the elements of the following sets. Given set A is the set of all x, x is an odd natural number. So let us list down all the odd natural numbers. So they are 1, 3, 5, 7 and so on. So this set is an infinite set. Next, second question. B is the set of all x, x is an integer, x lies between minus 1 by 2 and 9 by 2, which means that x is greater than minus 1 by 2 and less than 9 by 2. So what are the integers which lies between them? Let us make use of the number line to see the different integers which lie between minus 0.5 and 9 by 2 stands for 4.5. So we get the first integer to be 0, then we have 1, 2, 3 and 4. So the integers which lie between them are 0, 1, 2, 3 and 4. So we can find here 0, 1, 2, 3 and 4, which are integers which are lying between minus 1 by 2 and 9 by 2. So we can write set B as set B is equal to 0, 1, 2, 3 and 4. So this will be the roster form. Now let us write the set C. C is equal to the set of all x such that x is an integer, x square is less than or equal to 4. So if x square is less than or equal to 4, that means x lies between minus 2 and 2. So let us write down the integers which are lying between minus 2 and 2. So we get minus 2, 0, 1 and 2. So this will be the integers which satisfy this inequality. Now let us see question number 4. D is the set of all x. X is a letter in the word loyal. So as we have discussed earlier, when we want to write the letters of the word, we should write all the letters without repetition. So they are L, then we have O, Y and A. So L is given twice, but we should write only once. So we get L, O, Y, A. So this will be the roster form. Let us see the fifth question. E is the set of all x. X is month of a year not having 31 days. So let us write down all the months of the year which are not having 31 days. So they are E is equal to we have the first month February, which is less than 31 days. So this is the first month which has less than 31 days. Then we have April, then we have February, April, June, then we have September and also we have November. So these are the months which have less than 31 days. Next, F, the sixth bit. F is the set of all x. X is a consonant in the English alphabet which precedes K. So we have to write down all the consonants. So consonants are those letters which are not the vowels. So that which precedes K. So F contains all the letters of the English alphabet which are consonants that precedes K. So the first letter will be B, then we have C, D, E is a vowel, we can't write E, so we write F, then G, H, then we can't write I and we write J. So you got B, C, D, F, G, H, I. So these are the only consonants which precedes K. That means those letters which are consonants and before K. So these are the letters. I hope you understood. Question number 6. Match each of the set on the left in the roster form with the same set on the right described in the set builder form. So we have to do the match the following. Now let us see the sets which are given on the right hand side in the set builder form. So the first set is the set of all x. X is a prime number and a divisor of 6. So let us identify what is this set equal to. All the prime numbers and divisors of 6. So it is nothing but 2 and 3. 2 and 3. Then option B, we have the set of all x. X is an odd natural number less than 10. So let us write down what are the odd natural numbers less than 10. They are 1, 3, 5, 7, 9. So these are the odd natural numbers less than 10. Then x is a natural number and divisor of 6. So let us write down what are the natural numbers which are divisors of 6. So we have 1, 2, 3 and 6. And then the D is the set of all x. X is the letter of the word mathematics. So let us write down this. It's M A T H E. So we don't write M again, we don't write A, we don't write T, then we have I, then C and S. So we have 1, 2, 3, 6 which is matching with C. So 1 is matching with C, then 2, 3 is matching with A, and M A T H E I C S, the third one is matching with D, and the fourth one 1, 3, 5, 7 is matching with B. So this is how we match the sets. I hope it's clear. I hope you understood the first exercise, that is exercise 1.1. So if you like our videos, please like, share and subscribe. Thank you.